In this problem, we're going to be graphing a quadratic function using our graphing calculator by first putting the equation into standard form. So our equation looks like this, which is most decidedly not in standard form. To be in standard form, you need to collect all the terms on one side of the equation, leaving 0 on the other. If your equation's already in this form, which a couple math questions tend to generate them that way, then you could skip step 1 and move on to step 2. But for us, we need to have a little bit of work to do. So we have 2x squared, we have a subtract 4, I'm going to leave a little room in here, equals 8x. So the idea is to get this to be 0, since I have an 8x, I need to subtract 8x on both sides. So basically what I'm trying to do is just move this over and in fact put it right there. So what's going to happen on the right hand side then is 8x, if take away 8x is 0, so we accomplished that goal. And then we just collect these terms. Since these negative 8x is not a like term with these terms, the best I can do is perhaps put it in descending order to make it look nice. And now I can move on to step 2, which is graph the function on your calculator, and they even suggest a desired window setting to help us out there. And then eventually we're going to find if our solutions are real. We're going to find them using the intersect method. The graphing calculator will not find them if they're not real. So we'll see how that goes. So at any rate, it turns out you're going to need to type in 2 equations. So when I'm done with the video, I may put that in there, that you're not just graphing the function on your calculator, you're also graphing 2 functions. One function would be this guy here. So in my calculator in y1, I'm going to type in 2x squared minus 8x minus 4. But to use the intersect feature, you need 2 curves, and your second equation would be the 0. So we're going to get y equals 0 is a graph, which is basically a horizontal line through 0, namely the x-axis. And we're going to find out where those 2 things intersect. And the most solutions you could possibly get is 2. So you can get 0 solutions, you can get 1 solution, or you can get 2 solutions. So if they're real solutions, there'll be 2 of them, or 1, or 0. So I can find them on my calculator by going, well, I guess I already did some work here, but when you turn your calculator on, you start in what's called the home screen. And let me quickly get there. So when you turn your calculator on, it looks like this. Then you press y equals. I had already typed the equation in, but if you already have equations in there, hit clear. And I'm going to type them in. So it's 2 x, the squared key is here. Then remember we subtracted the 8x over, right there. So we're now going to type in subtract 8x and then subtract 4. Don't forget, as a second equation, you need to type in y equals 0. Otherwise, there's no intersection, and it would make any sense to use the intersect feature. So before I hit graph, I'm going to adjust my window settings. When you buy the calculator, it's in a standard window. If you ever wanted to graph in a standard window, the way to do that is to hit zoom and then 6, and it might not be a bad window, but maybe we will pretty it up a little bit. Since I'm not really trying to find the lowest point or anything at this point, I'm just trying to find the intersection. Zoom 6 actually isn't so bad, but I'm going to go to my window and change it up a little bit. My x-min is -6, so you don't even have to delete that. You can just type over it, -6. And then down to my x-max, which is suggested to be 10, it already is. Down arrow a couple more times to your y-min. The suggested setting is -17. That's to show off that vertex, that lowest point. And then it says the y-max only needs to be as high as 5. So perhaps this will look a little nicer if you wanted to see most of the behavior of the quadratic. In fact, all the usual interesting behaviors right here. You've got your vertical intercept, your horizontal intercept, and your vertex. So I've done step 1, I've done step 2, and it says if your solutions are real, which they are, they're both real. They're the intersection between the blue and the red. Now, on your calculator is probably not color, so you wouldn't see this red. In fact, you don't see anything at all because the x-axis is black, and your calculator usually graphs a black line over it, so you don't see anything. But you just have to have a little faith, since you have y equals 0 sitting in there, that your calculator didn't indeed graph this. So it crosses the x-axis twice. That means that both are real number solutions. The only other choice would be if they are what are called complex solutions, and that would mean that the parabola wouldn't cross there at all. So at any rate, I'm going to follow the directions. If your solutions are real, use the graphing intersect method to find them. So what I'm going to do is hit second trace, which accesses the calc menu. The second function of the trace key gives you the calc menu, and number 5 is the intersect feature. I'm going to press 5, and the calculator doesn't know I only gave it 2 curves. You know, it's thinking maybe I gave it 10, and it wants to know which 2 of the 10 am I talking about. So it asks this seemingly silly question: is this your first curve? Yes. You press enter, and then it pops to the other one, at least that does that for you, and says, is this your second curve? And you say yes by pressing enter. Then it says guess, and in this context, the guess is actually important. If you press enter right now and just guess in the middle, you actually can do that, and it's probably going to give you the one on the left, but it might give you the one on the right. At this point, since I have to find both, it doesn't really matter. I can just press enter and get whatever one I want. But I'm going to trace to the left just to show you that if you do trace to the left, you'll get the one on the left. The danger of putting the cursor over there is you might think that this is the intersection now, and that the answer is negative 0.18, but it's just a guess. You need to press enter for the intersect feature to actually run, and it's telling me at least to 2 decimal places, I believe it said. Where does it say that? Somewhere in here it should tell me how to round. I don't see how we should round them. Maybe at the bottom or something. Identify the real number solutions. Okay, right here, rounded. Identify the real solutions rounded to 2 decimal places. So I'm going to round this to 2 decimal places. It's negative 0.449 and negative 0.449 to 2 decimal places. Since this number is 5 or higher, I'm going to round it to negative 0.45. So one of my answers for the horizontal intercept is negative 0.45 comma 0 is a point on the graph. And then there's going to be another one, you know, and I know the y value is going to be 0 there, but, you know, what's that x value there, question mark. So let's go back to the calculator, and you can only find one at a time, so I literally have to repeat the process. Second trace, number 5 intersect. Is this your first curve, the blue one, the parabola? Yes, enter. Is this your second equation, y equals 0? Yes, enter. If you press enter right now on the guess what you're going to get? The same answer you got before, and I don't want to do that all day long. So I'm going to right arrow over. And trust me, if you were to right arrow over earlier, some students do that, it pops you back, which is very annoying. So wait to the third prompt where it says guess to arrow over, or you're wasting your time. And remember to press enter, otherwise you're just guessing. So I'm going to press enter, and to 2 decimal places, let me see, to 3 it's 4.449. Let's write that down, 4.4, erase that. 4.449. Again, this number is 5 or bigger, so I'm going to round it to 4.45, which means this right here should be 4.45. I'm going to have to erase all this stuff to get rid of that question mark. So 4.45 is the x value of the other horizontal intercept. So we got our 2 horizontal intercepts, and now we'll be able to move on in the directions. We've done 3. Step 4 is to draw the graph neatly below by plotting the highest or lowest point and one other point. And then eventually we're going to have to place a point on those intercepts that we just found. So we need to find the highest or the lowest point. That's going to take some work, but because the numbers are so easy, let me just erase all of this, and I've got a decent memory. Negative 0.45 and positive 4.45 are our answers. I don't want to lose sight of that. So let's see here. It was negative 0.45 and 4.45, and those were my horizontal intercepts. And now I have some room to show you how to find the highest or lowest point. So by now you should have done many problems where you find the vertex. This is a parabola where a is positive, a is 2, so we're going to have a parabola that opens up, as we already saw, and the lowest point is called the vertex. And the x value of the vertex is always found by doing negative b over 2a. So in my case, after I put things in standard form, that's necessary, when we subtracted the 8x over, after doing that exercise, we got that a is 2 and b is negative 8. So the formula says take the opposite of b, so b is negative 8, the opposite of that would be positive 8, and then you divide by 2 times whatever a is, and a was 2. So you basically have 8 divided by 4 here, and 8 divided by 4 is 2. So all that to find out that the x value of the vertex is 2. Now you simply only need to plug it back into the original equation, which would be very simple to do, but the video is already getting so long, I'm going to elect to go back to my graph and show you a way, since you've already done the trouble of graphing this. Let me down arrow so that I'm on the blue curve, which is the parabola, and as long as you're on the blue curve now and you're seeing coordinates, you can just press 2, enter, and it'll evaluate it for me. So when you plug in 2, you get out negative 12, and it sure does look like that's the lowest point. So 2 comma negative 12 is the lowest point. So now I'm going to be able to do step 4, which says to graph it neatly by plotting the highest or lowest point and one other point, and you have to use this, not the line tool, but the polynomial tool here. So I'm going to click on the parabola, and it says to draw it neatly by plotting the lowest point, which was 2 comma negative 12. Click and hold down. Here's my parabola opening up, and pick another point. We already have that one of the other points is 4.45 comma 0, which is somewhere in there, and hopefully that's close enough. The way he has this set up, you can see that it's a pretty discrete method. So this wouldn't be 4.45, and this wouldn't be 4.45. So right there in the middle is what we need to do. So we followed the directions. We plotted the lowest point and one other point. Now we need to place a point. Placing a point is a little different. To place a point, excuse me, you need to use this point tool. So you click on the point tool, and we're just going to place points where? On the horizontal intercept. So that was here, and the other intercept was negative 0.45, which is right there. Now it says, finally, below the graph, identify the number of real solutions. There are 2. We got 2 real solutions, and identify those solutions. So let's go down and do that. Identify the number of real solutions, whether 0, 1, or 2, well, 2. Identify the real solutions rounded to 2 decimal places. So it didn't ask for the points and full coordinates, just the solutions. So the way to do this is to type in the smallest one first, negative 0.45, and just separate it by a comma. I'm not writing a point, I'm just listing my solutions. So that would be 4.45. And you can go back and make sure that you answered all of the questions. But I think that's basically it. By the way, just to show you, in our example, the graph crossed the x-axis twice, and we had 2 real solutions, but it is quite possible for the parabola just to touch at one point. You know, even if the parabola opens down, it can just touch at one point. Or, and you would have had 1 real solution, or what can happen is the parabola doesn't cross at all. It just never crosses the x-axis, and that means there'd be 0 real solutions.